applause, Jessie.
Cool. Yeah, so I'm Jessie Frazelle. I'm a Docker maintainer, and I work at Mesosphere. So originally, when I had this talk idea, I was going to do like all these boring slides with like research about sandboxes and stuff. But I ended up spending all my time on actually a demo, of course, because I love talks that are all demos. And also in 25 minutes, I feel like a demo will be like way better than, you know, some slides with text on it. And also I'm really bad at that. So moving on, I think it would be good to start by clearing your heads of all like the stuff that comes with containers, because at the root of containers is really the basic primitives in the Linux kernel, which is, you know, C groups and namespaces, and then like mounting this root of S. There's all of these like daemons and orchestration devices and all that like it's cool and they're really neat and they fill a lot of the needs of like scaling this out to multiple like mass users. But if you just want to run like one container, it's kind of unnecessary. And that's like kind of where tools like unshare and like just small binaries, like Chrome even has one named mini-jail that I found the other day, come into play. And it's really nice, especially like runc is a great one. And I actually run, like if I look right now, I'm running Chrome in runc. So yeah, I mean, I'm a fan of like the very basic like single binary, let me just SCP this and then run it. I wanted to start by talking about kind of like what the goal was here, because the talk is called like application sandboxes versus containers. And if you're unfamiliar with application sandboxes, the best example of one is Chrome itself. Chrome spins up a sandbox for the browser to live in, and then actually even each tab in your browser is in a PID namespace, so that like all that crazy malware JavaScript that wants to like execute and take over your host won't do that and figure out like all the processes running. So it's actually insanely neat that they do this. They use almost all the same things that containers use, but containers almost get a bad rap when it comes to being a sandbox in general, and I wanted to try and maybe make them more of one. So the key differences that come into play here is, well, first let's go over the similarities, I guess. So, you know, Chrome uses namespaces and containers use namespaces, and then also Chrome uses seccomp, and we recently added seccomp to Docker, but it's been in runc for a while. And one of the things that Chrome actually does not use is C groups, and I'll get into probably why that is later. And also what containers use is C groups, which is actually, you know, a great thing for also isolating resource control. So C groups really are what a process can use, and namespaces are what a process can see. So it's nice to have both because they work very well hand in hand. And then another thing that containers really limit is capabilities, because you can set the capabilities that can be run from a process, like certain things that can be done. So one of the like big things that you may not have realized, because a lot of people run Chrome on a Mac, but if you ever start Chrome on Linux, just the binary itself, you don't need to like sudo Chrome, you just run Chrome. I think actually the binary itself is called Google Chrome, but it's running under your user. It's not running as sudo. And if you notice anything about Docker or most of the container tools out there today, you have to sudo run this binary. So that's one of like the key differences between how this is a sandbox versus not. So I tried to actually make it one by allowing you to spin up, you know, containers with your own user that is non-privileged. And there are some difficulties in this area because of a lot of the things that are baked into containers today. So we can kind of go over, I guess, what those problems are, but what I'll kind of just hit on them in the end. But so Chrome obviously does this. Obviously it's possible, and the way that Chrome like does it is by using a user namespace, because you can spin up user namespaces are the only namespace that you can use where you do not have to be sudo to create it. So with user namespaces in runc, this should be possible. You should be able to use runc as a non-root to user. And I have like a few patches that I use for like the demo that I'm going to show that I will eventually push upstream when they're less shitty looking. But yeah, this is the end goal here. So on a complete and utter different tangent than this whole like sandboxing thing, there's a story that I would like to tell because it's a basis of also this other thing I built. So like about a year ago, I don't know if anyone's familiar with Michael Crosby. He works on our, well, he's on the core team at Docker. He's also a maintainer of Docker. He came into the office and was like giving everyone this binary which had a rootfs backed like in the binary itself. So all you needed to run was the binary and it would pop you into a Debbie and Jessie container. And because in Golang you can just kind of throw some, base64 encoded tarball into a binary. It's cool. So I kind of built from that idea, took that and combined it with the whole non-sudo thing to create something that I think personally is pretty dope. So I'll show how it works a little bit. So I like don't know how else to explain the fact that like this binary has everything that you need in it. What it does is if we look at like, actually that's gonna be terrible, let's just do this. So I have this like go generate file, and if you're like unfamiliar with go generate as a concept, wow, I lost my mouse. Okay, there we go, sorry. So go generate is something that runs like while you're building a binary, so it's almost like a pre-build task if you're not familiar with Go. So what this does is it takes a image.tar, which is just like a rootfs that has been tarred up from a Docker image, and it reads the file and then it base64 encodes it so that you can have it just in your binary itself. And it actually looks really gross if I open that file because it's all on one line. It doesn't even take like new lines into account, but it's cool. So I don't even need to be like, oh, you have to download this image and then you can run it. No, it's like all in the same binary. So that's all part of a like pre-build task. So I built like a few of these out for various Docker images. So there's one for Alpine, there's one for BusyBox, CentOS, Debian, Fedora, all those. So what is also happening on the innards of this, that was a weird word, is it's creating kind of like a default runc spec for you with like sane things, and also because I just didn't want to have it be like, have to build in all these options, but you can actually choose at the command line if it's read-only or not. These are like the default caps. And it's a lot of the same defaults as Docker. It also has the same default seccomp policy as Docker, and everything like that, and it uses like every single namespace there is. So it's basically Docker all-in-one, very, very, very condensed binary. And all those binaries, you can tell they're owned by me, and we can just run one to kind of get the gist of what it does. So there it is. I'm like in this container, and you're like, wait, what just happened, right? Or not. So what actually it did with the rootfs that is embedded in here is it put it in the directory as, as just like a rootfs dir, which if you're familiar with runc, like the whole kind of layout is you have like a config and then you have your rootfs in a directory. So it really just extracted the tarball that was inside the binary to your host so that you had a rootfs for your file system. And as part of this binary that I built, I have it clean up the rootfs after, just because I like hate files on my host. And it would actually be really cool if it somehow just like abstracted away the rootfs entirely, but like I'm pretty sure that's impossible. But someone afterwards will probably be like, no, it is, do this thing, and then it will be cool. So yeah, the only thing that it really is saving on your host is that rootfs, but it's going to clean it up after. So everything in this binary is self-contained. It's like a static binary in itself. Like glibc is even in there. So it's really runnable anywhere on a Linux system, which is really cool, and you get everything that you get with like Alpine in general. But you know, like if I try to get network out of this because I didn't set up anything, it will just like totally flip out. And there's no IPs in here. If we look, I mean, all I have is a local interface. So this is like, how much can you do with this? It's kind of shitty, right? You can actually do a lot. So we can leave this one alone. In another part of just like running runc on my host, I built a small binary that allows you to create like network name. So it allows you to create vec pairs that you can clone into a container and then get network out. It can be used as a like pre-start hook for runc. And it will just set up networking for you, so you get network out. You also get an IP for your container, so you can reach it if you have a web server. So what I added to the like command line for these, and these are basically just all the same binary, but I named them different things because each one I compiled with a different rootfs. So if we look at the help for this, there's a flag for hook, and that allows you to set like a pre-start hook for various, it can be anything as long as it's an executable, which is really cool. So we'll run one with my like netns binary, which will set up networking for us. And probably the best one to show that with is nginx. I mean, isn't it nice when you don't have to type sudo? So I'm adding the flag pre-start with the binary that it will run, and then this nginx-g daemon off is actually like the command, the default command from the Docker image itself. So yeah, we can do that. And just like a little hint about what this binary does is it takes the IP that it set up for your container and it saves it in a .container file. So if we like, I mean .ip file. And you can like change that, there's settings in like the netns binary, but you know, this is just nice for now. Because ideally, like still I have a rootfs in here, which this one is now nginx rootfs. Isn't that nice that it like cleaned it up right after? So we can take this and we can curl it to see if it actually works. Which it does, which is cool. And then also, I mean, just to prove the fact that this is running as me, we have the binary running as me, and then we have nginx itself running as this, remapped root user. So if we take this PID, you can see that UID is mapped to root in the container, but it's like 886.432 on your host, same with GIDs. And if you do not believe me that it is running in all the namespaces, I can show you that it is. In fact, has all the namespaces set up for it as my user created this, which is so cool. I mean, to some people, it's kind of just like whatever, like I could just do this with sudo, but like to people who actually care about like not giving everyone on their, like enterprise infrastructure sudo access to, run shit, this is a big deal. So There's like a few other little cool things that I can show you. The nice thing about this make file is you can just like pass in actually any image and it will build it for you. But we can also just show Redis while we're here. And the command that I'm passing is Redis server because, yeah, that makes sense, right? And I'm also adding the NetNS pre-start hook here so that we get another IP. So there's Redis. If we go back over here, this binary is running as me, and Redis server is running as the remaster user. So we can like ping this IP. I don't have the Redis client on my host because why would I ever install something on my host? And it's like reachable. It's pretty neat. So it's kind of cool. There are some downsides, which I should probably go over, because in building this, it's difficult to take something which kind of assumed that you had root access and then start ripping away the parts that give you permission denied. So there's like a lot of places in the code base that just make an obvious assumption that you do have root access, because even in run C, the like main function, it checks that you're root and then it will exit right away if you're not. Mostly because, I mean, even VBATS and I were talking about this after, like, you don't know how far it gets and then you have to clean up all that crap when it like, gives you permission denied, and then you're gonna be stuck with your, production server having some random file somewhere that might, interact with something else. So first I obviously remove that. And then there's a bunch of stuff with C groups where, I mean, even if we look in here at the C group file system, it's owned by root. But then if we dive a little bit deeper, actually, into where things will be run, this user slice, well, that's interesting. So it's probably because I'm not actually running anything right now. Shit. So you can get like semi-far on actually setting things up. I'll show that. Right, okay, so like I said, the code that I used is pretty gross for this, which is why I'm not pushing it upstream right away, because I kind of just took out things that, that don't work. But it actually tries to set up C groups for this container, and it works pretty great being owned by my user. But if we dive a little bit deeper, there is this file called cgroup_procs, which it says it is owned by me, but you cannot write to that file as me. And I think like even VBATS was saying after, which I don't know the exact like problems in the kernel around this, but it's being worked on, I guess, which is great, because it's kind of a pain in the ass. And this is actually also why I think Chrome obviously does not use C groups for their sandbox, because if you can't get past this, then you like have to run as root. But it did get pretty far in this process. It just couldn't create any of the other things. Like even if we look at some of the subsystems, like Redis is owned by me. So it gets really far, and then right up at cgroup_procs on every single subsystem, it craps out. So that's one of the problems that still exists. But other than that, honestly, I think this is entirely doable as a concept to have non-privileged users run containers. And actually, even for the time being, I think, until this is fixed, maybe there should be a way to run containers without C groups, or maybe the C group thing could be a different binary with certain caps added on it that gets, you know, like put into a hook or something. So it's interesting and cool to me, at least, that this is entirely possible. And let's see, I can show a few others, but I'm getting close to time. By the way, I'm getting permission denied on these files because they're owned by that like really high up user, not because like it's something else. We can show like htop, which is probably a cool one. I actually did not run that one before this, so of course, like, why not do it now? Let's try it. Oh, I can pass the ID. It's a good thing I put that in there. Cool, so this one is still in a PID namespace, sorry. So obviously we only see ourselves. Oh, we could actually try something fun. Okay, let's like really get crazy. Let's find that PID. Actually, you know what I can do? Well, no. Yeah. Let's take this one, and then there is no bash in this container because it's off of Alpine. Do we have all the namespaces? Kind of looks like it, right? Yeah, so I am now root in the hostname of this container is CTR. It was like, that's hard-coded in there, sorry. It is freaking out about the git prompt. I have no idea why. Probably because it's still using my TTY. But now we have two processes in there, kind of cool. If we, I guess, like, so this container thinks it's root because of the whole user namespace free mapping, which is cool. Yeah, that's kind of about it, I guess. Any questions?